Dr. Rajan sir.
Sir, good evening, sir. Good evening, sir.
Yeah, I'm ready whenever you say. I will share my.
Okay.
A few more minutes, sir.
Sure.
Only
Just
10 has been joined till now.
Sure.
For MBA for both Narayana Engineering College Nellore and Narayana Engineering College Godur. Dr. Dhananjay sir has 20 plus years of teaching expertise, who is acting as Dean for MBA, and he has been faculty for ICFI School of Financial Studies since 2017. He has been worked as assistant professor for Vivekananda School of PG Studies for more than 6 years, and he received his BTech degree from SV University, Tirupati in 1992, and then he had his MBA degree, and then he has done his some of the courses from IIM. His expertise in branding things well, and at the same time, who has been expertise in data analytics, visualization. So we are very much waiting for the resource persons today's session. Sir, Dr. Dhananjay sir.
Sir, thanks for your.
Please proceed to the current today's session. We are all excited for the session today.
Yes, sir. I'm afraid I'm not an expert. I'm just a beginner. Right. I will try to explain some of these things.
Okay, sir. We are looking for statistics majorly.
Sure.
Analysis and all those things. Okay, sir. Please go on.
Let me share my screen.
Yeah, please.
Sure. Thank you.
Are you able to?
Yes, sir. Yes, sir.
Visible,
Right.
sir. Visible, sir.
For some comfort level, I will just try to show this R Studio for some time. Then I will switch to the context or the intuition behind these statistical exploration.
Right.
Okay.
So I will switch off my video so that it is more. It won't take much.
Sir, బాగానే ఉంది background అంతాను.
Okay. Fine, sir. So basically in this, though Dr. Rajan sir has now told that it is a complex statistical, but I go by simple methods. Some of the simple methods I will try to make sense of in this session. So here, basically what we are doing is we are examining some data. We are trying to make some sense of some data and trying to see whether there is any relation and whether we can make some decision from the data. Now I will just take an example, then I will go to that theoretical context. So basically here, I have taken a data from ISLR. ISLR is a very popular book. That is, their ISLR database is there. That is Introduction to Statistical Learning with R. So Dr. Bhash sir, if any disturbance is there, please tell me, then I will correct it. I think.
Okay, sir. No issue, please.
Yeah. Is it clear? That is, my screen is visible.
Visible, sir. Visible and audible, sir.
Yeah.
You please go ahead, sir.
So as you are already familiar with our studio, what our previous experts, Krishna Prasad sir and others have explained. So we have these 4 windows, and now what I am trying to do is I am importing or installing these packages like mass package, statistical package. So I will just explain this commands. So library mass, I am executing this, I am running this command. So it has got executed. So as you know, this R will not throw the output unless you specifically ask. So R will keep these things in an object form, and only if you ask, it will throw out. So next, like ISLR library also, I am importing. So these are basic commands, install .packages, and whether you want to invoke specific libraries, we do that. So one of the basic thing is that this is what is the working directory we are working in the R environment. So what is the directory we are working on? So right now what I have done is I have imported some data and put it in a specific folder that is in the D drive. So what data I am trying to work on is this advertising.csv, which is an advertising data set from the ISLR package or ISLR data, which is maintained by these ISLR people or professors from Stanford University, I think. This is a very popular book in terms of statistical learning. So most these things are used synonymously: statistical learning, machine learning, and analytics. So only thing is that the difference between statistical learning and machine learning, we use big data in case of machine learning, whereas statistical learning, it is a bit of models and small data where more of interpretation is there. Whereas in machine learning, we use large databases and large computational power. So let me, so then this advertising data is in a CSV format. So normally what R does is, R is very comfortable with the most popular type of is the data frame. So data frame is nothing but like what your Excel table, Excel sheet, where you have rows and columns. So columns is my variables, rows is my observations. So I am trying to read this CSV file. So when I have read this CSV file, is it okay? I think some disturbance is coming, I think.
Okay, sir.
Yeah. So here, what I have done is I have read this advertising data into an advertising object. The object can be named anything. For the sake of convenience, I have taken as an advertising. So I can see what is this advertising consists of. If I click on that, this will show me what is that advertising data set consists of. So it has 4 variables. That means all columns are called variables. And we have that observations, 200 observations. So as you can see, if you go down, you will see 200 observations.
Sir, mute the button, sir.
Okay, am I on mute? Hope all of you are clear. This is the data set I am trying to explore. This is a ready-made data set given by this ISLR database. It is even available in your Kaggle data, the open data sets. So this is a data set. Let me see. So first thing, whenever we have a data set is, now I want to inquire about what is the type of data it is having. Of course, here I have seen in the direct CSV file, but sometimes it may not be possible to see a CSV file because it may have lakhs and lakhs of rows. So then if you just not directly open the data, the system may hang, and because it's a huge data. So how to probe that database and what it is having? Just so first I will see this, what is the first 6 rows. So first 6 rows is what is having. It is showing TV, radio, newspaper, and sales. These are the first 6 observations. Now, most of the data analysis or data analytics are these things. Now we will go for summarizing this data. What is the summary measures of this data? The summary measures will give us, these are already, I think, our experts in the previous classes have covered. This minimum, first quartile, median, mean, third quartile, and maximum. So some of these things, because they are very important, I will come to it later when I take up this theoretical context behind this. Now I can now that is this data set consists, what it is saying. This data set is saying I have a company sales. I have 200 observations, and my advertising budget for each of the advertising medium. So I have 3 advertising mediums, that is TV, radio, and newspaper. What problem I'm trying to answer from this? I am given a question that how should I increase my sales? So as a manager, my perspective more of a business and statistics, because I'm not into core programming. Hope I think you will understand that. So my question I'm given is how to increase my company's sales. So how can I do that? I can't go directly and increase my company sales. So what I have to do, I can increase my advertising budget. So advertising budget is my proxy or my tool for increasing my sales. I can't directly increase my sales. So my question is whether I have to increase my budget on TV, whether I have to increase my budget on radio advertisement or newspaper advertisement. So that whether I can have some intelligent idea from this data. So what it is going on, everything is going on based on data. So I can't have a hunch, I can't have a gut feeling that you increase radio, you increase newspaper. I can't randomly say. So now, because we have data available, algorithms available, some statistical methods are available, I want to know everything is data-based decisions, or what we call evidence-based. Everything, either evidence-based medicine, evidence-based analysis, evidence-based trading, all these things. So whether you go to finance, healthcare, retail, everything we are trying to collect data and subject it to statistical methods to gain some knowledge. So after all, data is not useful unless we convert data to information, information to knowledge, knowledge to insight. That is what the famous data science cycle says. Or this data science people says that this is this data science profession is the most attractive profession. So I want to see what type of relationship exists between these variables. So this is how I go about inquiring or querying my data. So I will try to see what is my summary of the data, what type of summary measures we have. Then I will try to see what type of relationship exists between these variables, two at a time up. So I will just see. So now you have a plot here, and the bottommost right hand side, which shows me, because there are these variables: TV, radio, newspaper, and sales. What type of this is what we call scatter plot. So what type of data is distributed here? So this is how the data is distributed. Of course, again, now this again, yesterday I think we have seen. I will just try to see what type of a model or what type of regression we can do in this data set. So if what I have done is I have done a linear model. So here what I have done is I have fit a linear model between sales and three types of advertising budgets. So as you know, as a common sense says that what is our dependent variable? Dependent variable is the sales. My sales depend upon my various forms of advertising. So whether it may be TV advertising or radio advertising or newspaper advertising. So these three are the independent variables, and the sales is a dependent variable. So my premise, my hypothesis is that I want to find out where I have to increase my advertising budget. Okay, so I have fit a linear model. That's what our within with a simple one-line command will give us the linear regression model. Of course, this model is not directly visible to us. I have sent it to an object called add.lm, so that this add.lm I can selectively query or take whatever output I need. So that is the beauty of R, that it always throws into an object, and this object can be queried or used for whatever purpose we have. So if I want to see what is the summary of that summary output of that regression, I can take the summary of that. Sorry. So you can use Ctrl+L to clear your screen so that it looks nicer. So I have taken a summary of this linear regression model. The summary throws various outputs. I will explain it in the diagram. So it has, I think yesterday also had some discussion where the summary throws out my coefficients and standard error, t value and p value. So basically my regression equation is sales is equal to beta naught plus beta 1 TV plus beta 2 radio plus beta 3 newspaper plus error. So always we have to remember that this always this error term is there. What is the equation for a straight line in mathematics? Y is equal to a plus bx. Okay. So if I add y is equal to a plus bx is a mathematical equation. But if I add y is equal to a plus bx plus error, then it becomes statistics. Why? Because y is equal to a plus bx is a completely determinate. When error comes, it becomes probabilistic. So we are introducing probability because we are dealing with the forecasting problems in this statistical analysis. So always in our model, there is something called error. We are assuming that there is a linear fit between sales and various advertising budgets. But it is not always perfectly linear. There is some deviation, and that deviation we are trying to fit an algorithm by using this regression. Is a lot of regressions are there. Different types of regressions are there. Simple linear regression is this is the most basic and foundational concept in statistics. All other things are extensions of this regression. These are basic foundational concept and very useful. So this simple linear regression, that means we are fitting a straight line to our given data. So we have both the inputs and outputs. As you are seeing, no, this there is a 200 observations, 200 observations of 4 variable inputs and 200 outputs. 3 variables. Okay. 3 variables in the sense 3 independent variables, 1 dependent variable. So for each set of 3 independent variables, we have 1 output variable or dependent variable. So I know what is the correct output for these given 200 data points. So the computer knows if I give these 200 input data, I should get this output data. So what I am trying to do is I want to calibrate my model using this. So what I want to do, I am trying to fit a algorithm so that this y is equal to beta naught plus beta 1, TV plus beta 1, newspaper plus beta 3. These 3 things are there, no? So plus error. So I am trying to minimize my error by trying to see what is the inputs and outputs. That's why this regression is called a supervised learning. That means I am having both output and inputs. I am trying to calibrate. I am trying to get best fit. That best fit is obtained by ordinary least squares. What do you mean by ordinary least squares? I am having a predicted output. I am having actual output. I am trying to minimize the difference between these two by taking a square of that difference, or what we call sum of squared errors. I am trying to minimize SSE, or I am trying to minimize sigma SSE. Okay. So this sum, doing some the calculation, I will find out what is my beta naught, beta 1, beta 2, beta 3. What is the best fit for my given data? Okay, now I think this is the context. I will try to see what is the theory is saying for our this type of problem. Let me share my screen. I have to search for it. Are you able to follow, sir, in the, till now, how we are trying to go?
Yes, sir. Yes, sir.
If there is any no questions, clarifications, or suggestions, you can share in the chat box. We'll try to.
Sure, sir. Audience, please respond.
If we are going in the right track, then we will.
Sure, sure.
I'm trying to share the screen. Just bear with me. It may be some basic for some of you, but I'm trying to make some sense of this statistical intuition behind these algorithms and softwares. Dr. Bhatt, sir, are you able to see the screen? I'm trying to share a PPT.
No, sir.
Okay, okay.
No, sir. We are unable to see your screen.
Yeah, I will just.
Okay, okay. Now visible, sir.
Now visible, sir? Yeah.
Yes, sir. Yes, sir.
Yes, sir. Visible.
Yeah. Thank you.
I think all of you are, I think because you are in the basic slide we put in the data science is this, the model or data science life cycle,
Okay.
where we import the data and clean that data. So we import data by using, the R can connect to either your Excel file or web scraping or databases or APIs, all these things. And they have that, better how R can get data from all these sources. And we clean that data. We have different packages for cleaning that tidyr and all these things are developed. And then we have visualization model. These models are supervised learning models and unsupervised learning models. So these models, like one of the basic model what we discussed is a regression model. So, and then we communicate using various tools. Like we have very good packages like ggplot and all these things for visualization, beautiful graphs. So I will just go some of these intuition behind these basic stats. So what we're trying to do is, all our statistics or why statistics or why this thing, this is what we call scientific method. We are trying to go for a scientific method rather than some intuition, that is rather than some gut feeling or some non-data based things. So all, as you know, the statistics comes into a picture in all our areas of our life. Like, we want to find out what is my chance. So because basically statistics deals with chance. That's why we say that it is that is we are operating in a probabilistic world, not a deterministic world. If everything is deterministic, it becomes mathematics. Because there are some random things, because there is a probability, because there is a chance, we are going and taking help of statistical models. Okay. Am I making sense? Why? Because statistics explains the variation in the data. So our basic aim of this machine learning or statistical learning is whether a thing is happening due to chance or whether it is any significant effect is there. I want to remove chance variation in the data. So what is left is the significant variation. I want to understand whether this phenomena is occurring by chance or is significant. So that's what this slide also says. In some of the other seminars also, I try to explain. We have two types of evidence. One is anecdotal evidence, another one is empirical evidence. Empirical evidence is based on data. Anecdotal evidence is based on gut feeling. That means suppose I am starting from my home and a cat comes before my car. So my wife immediately says, no, don't go by car today, or today don't go to college. I may be having a lot of meetings and all with the director, sir, then I am, because I am in a hurry. So this is what you call anecdotal evidence, because she has gone outside after seeing a cat and something bad may have happened. But what is the scientific way of approaching this problem? Scientific way or empirical evidence, scientific method says that you take 30 observations of cat crossing your car and record what happened. So this is the input is cat coming before your car. Output is what is the outcome or what type of positive or negative things you have done. They have occurred to you. And take the average of that. Then only we can decide whether the cat coming before my car is positive or negative. That is what we call empirical evidence or scientific method. Of course, there may be a lot of superstitions or what we call beliefs, where we send a rocket to in the space. Before sending a rocket, we may we may break a coconut and pray. That is different thing. So I think I'm making some sense here. So no, what I mean to say is what we understand is all these things somewhat synonymously, where we deal with data, business analytics, data science, machine learning, statistical learning. These somewhat overlap is there. Because it's a multidisciplinary things where statistics is there, computer programming is there, business is there. Because after all our programs or all our software systems are trying to address some business need, some business problem, then only the money is there. So the money will come from corporations trying to solve their problems. So I think also, so even at the cost of repetition, I'm trying to, because this might have been covered yesterday also, I'm seeing, I have attended that Dr. Prasad sir's class also. So basically, we have three types of statistical models or analytical models, like descriptive models, predictive models, and prescriptive models. So this descriptive analytics is the use of data to understand what happened in the past. So some of these descriptive models, what we are having in this descriptive analytics, So in this descriptive analytics, I want to describe the data. So having an understanding of the data is very important. If somebody throws at me some 1,000 data, I can't make sense of it. Suppose I say that what are the marks of all engineering students in Narayana Engineering College in Nellore. So my assistant throws at me some 2,400 data points of marks of each student in NEC and Nellore. So that doesn't, that is very confusing for me. So I will ask him, find out the average marks. So then I can make some sense of it. Even average not sufficient, I will ask him what is minimum and what is maximum. So why I ask him minimum and maximum? So that I can understand the range of it. Okay. So sometimes what happens is, even that average is somewhat very deceptive. Like suppose I say, what is the average of 3 children, average age, who are having age of 3, 5, 7? Can anybody answer this? Average age of 3 children having age 3 years, 5 years, 7 years.
Six.
Any answer from the participants, sir? 3 children I am having, each of age 3, 5, 7.
Yeah, 5 only, sir.
Five, sir.
5, 5. Great, great. So now I will frame that question differently. The average age of my children is 5. I am having 3 children. Can you tell me the individual ages?
No, insufficient data, sir.
Insufficient. Why insufficient data?
You have only the average, but we have 3 variables, 3 variant ages.
Yes, yes.
So it is insufficient.
So I know the total. Total is 15.
Okay.
So 15 can be divided into various ways. There is various ways.
Yes.
So I
There
can
will
say
be
that.
several answers for your question.
Sir, yeah, several answers. Sir.
Yeah.
So that is where statistics comes. So my age of my children can be 1, 13 also. In an extreme case.
Yes, sir.
So I need some more information about the data. I need some more characteristic of the data, quality, that is how I can describe the data. Some more information I need. I will tell one more example. So I am traveling to my village. And in the village, I encountered a river. And some of the, my friend has told, who is there, he says this average depth of this river is only 2 feet. You can walk and get out other side of the river. Is that information sufficient for me to walk on the river?
No, sir.
Why?
So definitely we need to know the length of the river.
Okay, length is okay.
At which point the depth of water is 2 feet. That is important.
He is saying average depth is 2 feet.
Okay.
Average depth is 2 feet.
Okay.
What am I missing here?
Requires minimum and maximum.
When I'm trying to cross the river, I am drowning. So my river is 2 feet at one point and 10 feet another point, like that. Because I'm only 5 feet, I'm drowning completely at 10 feet point. So that means I am neglecting the variance in the data or standard deviation of that data. So there is something a very different animal, very dangerous animal called standard deviation or variance. The square of standard deviation is variance. So my distribution, the data distribution is not sufficient. That is, average is not sufficient. So there is something called sigma. Sigma is very important. So why? Because if I represent average as mu and standard deviation as sigma, unless I know both of them, I can't make sense of the data. Because even if because in this sense, I assume that the data is a normal distribution. So a normal distribution, the data can go up to plus or minus 3 sigma. Now, suppose my friend says that there is average the depth is 2 feet, but the standard deviation is 3 feet. Then I know that at some point of time, it can go up to mu plus 3 sigma. So that means 2 feet plus 9 feet. That means 11 feet. There is a danger that there is a point that 11 feet is also available in my distribution. So that is how we try to understand the intuition behind the data. This understanding of that is what we call, suddenly we encounter this mu plus 3 sigma or mu minus 3 sigma events. Then are what we call outliers. How many of you heard of normal distribution? I think most of you might have studied normal distribution or Gaussian distribution. Can anybody respond?
Sorry, a little bit, sir.
Okay. Okay. No. My only thing is that just to try to focus on that, because why these things, all these are background of this data science, or all these things are very much important. Statistical learning, machine learning, to have a grip on the foundational statistical methods. So this normal distribution is not that is a not very normal. It is very abnormal things will happen, or what we call Gaussian distribution in memory of CF Gauss. So what I mean to say is, many of the things that is happening in the world, that is we are modeling, we base it on the normal distribution. In finance also, we say that stock returns, stock market moves along a normal distribution. So all our models are built on that, and we expect that maximum it will move normally 1% plus or minus, like that. But suddenly stock market goes down 10%, 15% in a day. So people are wiped out. Traders or investors are wiped out, because these events are there in the tails of the distribution. Tails are where? Tails are in the plus 3 sigma, minus 3 sigma, outside of that. So like recently you might have seen, Facebook has fallen by 25% in one day. Because you are all in the IT field, you might be knowing that this is a very huge movements in these technology companies, and Google has gone up by 25% in one day. So because there is a lot of that uncertainty in those what we call new age technology companies, NATCs, all these FANG companies, Facebook, Apple, and all these things, Netflix, Google. So this is how we understand these statistical models. And yes, we have already know the descriptive statistics, and next type of thing is inferential statistics. Inferential statistics says that I am trying to draw conclusions from a population based on only some sample data. So because only what is available to me, sample is available. Population is not available to me. Like suppose in Nellore, I want to know how many people are favorable to some X party. I don't want to get into controversies. Suppose I want to know how many voters in Nellore town are favorable to some X party. I can't get hold of all the voters in Nellore. That is a somewhat tedious task, costly task. So I will select one person from Balaji Nagar, one person from Vedaipalam, one from Trunk Road, like that, and then I try to make sense of that data. So that is what you call your sampling. So in statistics, that is what we call. Suppose I will just, in the interest of not losing your interest, not keeping you interested in this subject, I will just tell a story. This story is like this. Some 100 people are traveling in a boat in a river. And suddenly in the middle of the river, there is a big storm. And his boat is trying to capsize, and the boat is falling down into the water. So all the people started praying to God, because whenever there is a danger, there's a huge uncertainty. So this uncertainty is different from risk. So everybody prayed to God, and 50 people, they have they have got some 50 people have drowned in that river, and 50 people have reached the shore by swimming or some other. So these 50 people, the press people have come, and press asked, how we have reached the shore, how we have survived. So they said, we prayed to God. Okay, then the newspaper has headlines that because of prayer to God, these people have survived. They have put a lot of slogans, so many things. God is great, something like that. But what happened to the 50 people who have drowned in that river? They also prayed to God. That is called survivorship bias in statistics. Or what we call, the world knows only the history of the survivors. History is told by survivors. So that's how the statistical thinking goes. Okay, that's what these very famous problems of survivorship bias. I think these all we have discussed yesterday and previous slides. Sorry, am I making sense? If any clarifications or comment sessions, I can take up.
So very nice, sir. Please go ahead in the same direction.
Thank you, sir. Thank you. So what I'm trying to see is that what is behind these statistics? Why we are doing this? Why we are what is the intuition behind this? I just wanted to drive. So we have seen about mean. Now one more example I will try to tell you. This why this mean is deceptive. Why this average is a misleading indicator. Suppose I have now, what is the average salary of computer science lecturers in NECN? I hope I am not going into a controversial topic. So I get some figure. So for simplicity's sake, take 1 lakh rupees. Or average wealth, you take some average wealth or something like that. Now, Bill Gates comes to my group. Suppose Bill Gates joined NECN. Now, what is the average wealth of all the faculty in NECN? Because Bill Gates is one of my faculty. So I am having 1 lakh rupees as average of ex Bill Gates. And including Bill Gates, it goes up to crores. So then if I go to my chairman, ask, raise my salary, means say, no, why? What is the average salary is 1 crore. How can I raise? So here median comes to rescue. Median says, don't go by the average. First put all the data in the ascending order. And take the middle point. So here the deception is eliminated. Now I know what is the median salary or median wealth of people in this distribution. Just I want to try to drive the, what is the intuition behind these things. So this we have seen. So ultimately, statistics is about understanding variation in the data. How much of the variation I can explain? What are the tools to explain my variation? What type of models I can fit? Whether my variation is occurring by chance or there is any significant difference in that. So that goes into inferential statistics. So there is a concept called, you might have come across this. One of the important things about inferential statistics is what we call hypothesis testing. So maybe for the purpose of not boring you, I will just shift to R. There we will see what is happening. So let me share my screen. The R studio screen. I will just wait. Dr. Basha sir, are you able to see the screen? R
Sir, yes, sir, yes, sir.
Sir, yes, sir.
Able.
Visible.
So I try to see some descriptive. Now I will come to this inferential statistics or models. So what I have done here, is I have 4 variables and 200 observations. My observations are in the rows, variables are in the columns. And the most popular thing is your data frame in the R. So trying to address how to increase my sales, I have fit a linear model, a linear regression. So my linear regression is throwing me the summary of that yard.lm object. That object is a output of that regression. So what it is saying is that this is the output. So bottom left-hand corner, the output is saying some minimum, first quarter, quartile, median, these things, and again coefficients. Now, first of all, I have formed a hypothesis. What hypothesis I have formed? I have formed a hypothesis that is called null hypothesis. So there are basically 2 types of hypothesis, null hypothesis and alternate hypothesis. In alternate hypothesis, I will keep which I want to prove. In this case, what I want to prove that there is an effect of advertising on the sales. So alternate hypothesis, I say that there is an effect, there is a significant effect of advertising budget on the sales. Opposite of that, I keep in the null hypothesis. Null hypothesis, I keep that there is no impact, there is no effect. So that is my null hypothesis. Null hypothesis says that all these coefficients are 0. So what I want to prove, that is in the alternate hypothesis. So to simplify, I will just tell you. So this is something like our criminal justice system. The criminal justice system says that all accused are innocent unless proven guilty. So here what I want to prove, some person comes to my court. What the court wants to prove? Court wants to prove the alternate hypothesis is that this person, X person, is guilty. What is my null hypothesis? X person is innocent. So I want to gather sufficient statistical evidence to reject H0. So H0, my H0 is, or the null hypothesis is that this X person is innocent. So I have to prove to the court beyond doubt that I can reject that null hypothesis so that he can be sentenced. So all my, if you just no, pick up this one concept, I think that goes a long way. What I am telling is, I have taught statistics to my daughter, who has studied my integrated MTech in University of Hyderabad, and she has got A+ in that, and she says, "No, Daddy, this is a very good foundation you have given." And she has gone on to do her MS in data science from University of Texas at Dallas. And I am proud to say that she has got 4/4 in her first semester. She says, thanks to your statistics, I am able to understand the machine learning and all these topics. Not to boast, just I am trying to drive this point of hypothesis testing. Because this is where a lot of confusion or what we call clarity is needed. So hypothesis testing is a simple thing, is that what you want to prove, keep it in the alternate hypothesis. Opposite of alternate, it goes to null hypothesis. So in the case of criminal justice, I want to prove that that is accused person is guilty. So I say that in the alternate hypothesis, this X person is guilty, and null hypothesis becomes this X person is innocent. Suppose I can't reject the H0. So the judge will not give sentence. It says that you don't have sufficient evidence to prove that, to reject H0. I have to build sufficient evidence so that I can reject H0. There are only two things: either reject H0 or don't reject H0. There is nothing called accept. In hypothesis testing, there is only reject H0, don't reject H0. Don't reject H0 means you don't have sufficient evidence. The judge says that, judge does not say that whether he has done that crime or not done that crime. He says that I don't have sufficient evidence. That is the whole philosophy or intuition behind hypothesis testing. So in this hypothesis testing, what that model says, I will again come back to this linear regression model. So in this linear regression model, what it is throwing the output? So my model is sales is equal to beta naught plus beta 1 TV plus beta 2 radio, beta 3 newspaper plus error. So in case of TV advertising, I am getting a T statistics of 32. And radio, I'm getting 21. Newspaper, like this I'm getting. Now, first thing we have to see is am I making sense? Dr. Basha sir, is it okay?
Okay, sir, please.
So two things you please observe. One thing is that there is a one statistic called F statistic. F statistics and R square, multiple R square and adjusted R square. F statistics is saying that 570.3. So what is this F statistic is telling us? Whenever this F statistic is high, okay. Now, okay, let me frame like this. What is my null hypothesis in this model? Here it is given. Here, can you see this 16th line of this my console?
Yes, sir. Yes, sir.
That is the script. 16th line, what it is saying, test hypothesis H0 is equal to beta TV is equal to beta radio is equal to beta newspaper is equal to 0. So basically, my null hypothesis is that they are not having any effect on the sales. Now, if I get a high number for the test statistic, I can reject H0. The test statistic of F statistic says that my results are not due to chance. There is some significant variation in the data. Okay. So F statistic is high, 570.3. So then I say that I reject my H0. What is my alternate hypothesis here? There is a relationship between advertising and sales. My null hypothesis says that there is no relationship between advertising and sales. My alternate hypothesis says there is at least some relationship. At least one of the independent variables are impacting the dependent variable. That means either TV or radio or newspaper, at least one of the beta is non-zero. Okay. So that means I am rejecting my H0. And one more thing to understand the model is what you call R square. What I'm getting R square, I'm getting 0.8972. What do you mean by this R square? R square tells us about the reliability of my model. R square tells me what is the explanation of my model gives me. So what I have one dependent variable and three independent variables. My dependent variable is my sales. My independent variables are my TV advertising budget, newspaper advertising budget, radio advertising budget. So my R square of my model tells me all these three variables explain 89% of my data, because it is in the points, or if you convert into percentage, 89.7% of my data, that is the output, is explained by the combination of these three inputs. How much my model is explaining the data. So after all, a model we are assuming, we are simplifying. There is always error. So if I am able to build 89% reliability of the model, 89% of the variation in the output is explained. So that is a beautiful model. Even if you explain 10%, 15% also, it is considered in a very nice, I will tell some example for the sake of not boring you. This is a very popular example in data science or business analytics. How some retail company, this is a target retail company, like Walmart, we have target stores. Have any of you heard of this example?
No, sir. No, sir.
So there is a this target retail chain. It collects all the customers' data, because we have used customer point of sales data and all these things. Now we have scanners, you have CC cameras and all. What type of products they are keeping in their basket. This is a very popular method. Again has come is a market basket analysis, MBA, not my MBA. It is a market basket analysis. That means what customers are keeping in their baskets. Because if you go to large format stores like Metro, DMart, all these things, they keep on changing their display items. Sometimes they keep some things in the front. Sometimes they steal items in the front. Sometimes they use plastic items like that. They keep on changing. And also what comes adjacent to what item is also important for them. So they have studied all this data and sent a mail to one person. So they keep on this advertising mails, like recommender systems. They keep on recommending depending upon our purchase data, depending upon our viewing data. In case of social media, like this is nice for you. Watch this video or like that. So they sent these mails. This product is there. And what they have found out is that this lady shopping on that Target, the Target store, they said that she is pregnant. But that girl is not married. So her father has said that I will sue you, for so many millions of dollars, because in USA legal things are very costly and very common, because they are very much conscious of their rights and all these things, privacy and all these things. But when actually the long story short, to cut it, so actually what they have they have done some market basket analysis, where they say that some milk is picked up by customers when typically these two items go together when people are in that cycle, pregnancy cycle or whatever they have. So that's how there's a very famous case. You can go through in this Google or YouTube how data science is used by Target and what is that controversy. So this is okay, again coming back to our model. So this is how the R square tells us how much strong our model is, how much percentage of the variation is explained by our model. Okay. So this is how, and if you see, this is a regression output. Now, if I want to find out whether the relationship is linear or not, I can draw a plots. That is a plot of that object. So my object, for simplicity's sake, I have kept it as add.lm. So if I run this command, that means I get is diagnostic plot or what? How much regression? So basically what I am trying to do, I am trying to fit a line. So here I can see how this red line is fitting to my data and what is the differences. So I am predicting some value, there is an actual value. So what is the difference? And this is how my regression algorithm works. I can see what type of residuals are there versus fitted. So that means there are some statistical points are there. That is whether it is whether there is collinearity in my independent variables. All these things I can investigate. And one more thing I forget to tell, that is I can also draw a correlation plots also. Let me see if I can do it in R. So QQ plots are no, whether that straight line is fitting to my data. Let me see whether we will get beautiful plots in R using this GG plot. So I now take the correlation coefficients of my advertising object. Okay, you excuse me, I think I'm unable to run this command. Let me see if, yeah, I think it has worked. So this car plot gives me what is the type of correlation between all these things. This is a beautiful visualization. I think you can do some adjustments. There's a left hand, this, it can give. So it can give numbers also. What is my correlation matrix? So this is how we scientifically go for investigating data. So first, where the correlations we see, if the correlation is there, then we go for fitting a model. So if the correlation is strong, say TV is 0.78, radio is 0.58, whereas newspaper is less. Here itself it is showing newspaper is only 0.23. So TV advertising is strongly correlated with my sales. And again, one more thing, it is very important here. Just because correlation is there, there is a causation. Correlation is not causation. Another statistical thing that we have to learn is correlation is not causation. If two things are correlated, we can't directly fit a regression model and say that this is causing this. We can find correlation between any two data sets by throwing finding by statistical analysis. So there may be no correlation between various things. Suppose we have rainfall in India is correlated to some stock market movement. We have found out by doing some analysis. Then I can't conclude that rainfall in India is causing stock market movements. And this is what the first example I given. Whenever a cat comes before my car, the car is getting accident. That means there is a correlation. Then I can't conclude that the cat is causing my car accident. So that is what we call by, we say that no, correlation is not causation. So these are the things we have to study as a background of machine learning or statistical learning. So all these regression, what I can say, it is a supervised learning. Whereas in case of unsupervised learning, there is no supervising output. I will just throw the input data and the computer figures, that algorithm figures out. And like you might be knowing very well all these supervised learning methods, classification and all, where I give some images of this and then the computer will learn by either success or failure how it is classifying that. So this is how I try to show some examples. If any other questions or clarifications, suggestions, your feedback is most welcome. You can put in chat box or you can unmute and interact. I will be more than happy to see your reaction, sir. Dr. Basha, sir, any comments or any type of clarifications?
No, sir, not yet.
Yeah, you just.
The-
Meanwhile, I will.
Everybody is understanding, sir,
Yeah,
as to what you have said.
thank you so much.
No queries from audience, I think so. Audience, please respond if you have any queries. So please feel free to ask our resource person. One query, that is correlation versus covariance.
Okay.
Correlation versus covariance.
Yeah. So basically here, I say that my correlation is 0.8. Correlation between two variables, say sales and TV budget. That means this correlation is a number. Then I say that strong correlation exists between sales and TV budget. So it's a ratio. Correlation is a ratio. Whereas covariance doesn't give me. Covariance says that it is some there is some 70% something like that. But that correlation coefficient gives me a ratio. Correlation coefficient is nothing but covariance by sigma x, sigma y. Covariance of x comma y by sigma x, sigma y gives me a ratio. Whereas covariance is a number which we can't make sense of. So this is something like body mass index. If I say that I am weighing 80 kg, I don't know what's the relative. Correlation coefficient gives me a relative sense. So that correlation coefficient will help us to compare. I hope I'm able to make some sense here.
Yeah, Rashmi ma'am.
Yes, sir. Thank you, sir.
Okay, thank you, thank you.
Any other queries? I'm trying to share some slide. I open, sir. I am not able to get hold of that. So this what I found is this introduction to statistical learning with R is a beautiful book. It is written in very simple terms, but it goes into the very depth of things and how
Best analysis tool.
sir, yes. I will just, yeah. Are you able to see my slides, sir?
No, sir.
Oh, okay.
Studio only.
Let me go to that.
Yeah.
Our studio, yeah. Now are you able to see, sir?
Yes, sir. Yes, sir. Now visible.
So this is what we have tried to discuss till now.
Yeah.
I will just run through for 5 minutes, then we can call it a day.
Okay.
So this is how what is intuitively telling us that the data is not linear, but we are trying to fit a linear relationship. So there is some error. So what you can do for any data, you can fit a straight line. So that our algorithm in case of linear regression is a ordinary least squares or OLS method, where we are trying to minimize the deviation between what is my straight line and what is my data. So what is the deviation between them? So this is what the questions they are asking for my data set, advertising data set, that we are trying to inquire. Is there a relationship between advertising budget and sales? What I have done, I have fit a multiple linear regression, and we are using F test and R square. If they are significant, then I say that there is a relationship because their high values it is throwing. So my null hypothesis is that there is no relationship between advertising budget and sales. I am able to reject my null because of high values of F statistic. So I surmise that there is at least some relationship between at least one of the betas is non-zero. That means at least one independent variable is affecting the dependent variable. Then how much that is affecting, I will go to my coefficients. Whether coefficient T statistic is significant, then I say that this particular thing is affecting. So this is how my scatter plot is there. So in this scatter plot itself, I can see that TV and radio are fitting nicely with my data, whereas newspaper is a lot of variation is there. So I can surmise, I can suppose that newspaper is not very impacting. Newspaper budget is not very much impact on my sales. So this is what my equation I am talking about. This is the model. Y is equal to beta naught plus beta 1 x plus epsilon. Epsilon is the error term. Beta naught is the intercept and beta 1 is the slope, or coefficients or parameters. So here what I am, after estimating, what I will get is a hat. Y hat is equal to beta naught hat plus beta 1 hat plus x. So why I am putting hat on this? What is the difference beta naught and beta 1 and beta naught hat and beta 1 hat? Because beta naught hat and beta 1 hat are estimates. After fitting my regression line, I come to know about beta naught and beta 1. So y and x are data from the population, and this y hat and x are from the sample. So these are estimates. So what I am trying to do in all my supervised learning algorithm called linear regression is only I am trying to minimize my errors or residuals. So yi is my original data, yi hat is my predicted data or estimated data. So what I want to do error, that's ei. I want to minimize sigma ei square. So this is what we call residual sum of squares. Residual sum of squares is nothing but I am estimating my yi hat, original data is yi. So how much it is deviation? Okay, this is how my algorithm is working. This is a mathematical relation. We need not worry about it because software itself takes care of all these things. So earlier the huge calculations there, like R has come and it has become very beautiful. And within one single command, you can throw out all these things and beautiful visualizations using ggplot and all these things. So that makes it attractive. And I can say that one of my professors used to say, the R is an addictive environment. R addicts you like, your smoking or drinking and all these things. So you become addicted to R, maybe nowadays Python, I think. So how, but beautiful statistical language or, this, machine learning or how to drive intuition into this data by using R statistical software environment or language. So I hope I have done some sense in this by presenting to you.
Yes, sir. Yes, sir.
Oh, sorry, I think we have time till 8 o'clock. No, I'm under the wrong impression that. No problem. We'll run through these slides. Some more, if anybody is having any type of clarifications, I will do it.
Sure, sir.
Because earlier I'm under wrong impression that we have done some data science using R where they run from 6 to 7:30.
Okay.
So I can go through slowly these things. Any other questions, then we'll take up.
Okay, sir.
So I hope you are comfortable with this linear regression. Yesterday also we have done some of these things. So this is how this hypothesis testing, what we have discussed also. I think Dr. Basha sir, I don't want to
Sir.
prolong anything. If any questions are there, we'll try to discuss and.
Okay, sir. No issue. And someone is asking about explain p-value.
P-value, oh, very good question. You know, sometimes in these things, we assume so that people know everything, because unless some questions are there, it will provide us some scope for more discussion and clarity.
Yeah, yes.
Okay, I think, see in this slide, see here, in our example, we have got very good slide here. The output, suppose I run a regression on my sales to TV budget. So what type of regression? I have a simple linear regression. That is sales is equal to beta naught plus beta 1 into TV budget plus error. If I run that regression, this is my output. What is my output? T statistic of TV is coming to how much? 17.67. And P value is saying that 0.0001. But the basic intuition is, if T statistic is coming greater than 2, we say that it is significant. Now, tell me, suppose I run a linear regression on sales and TV budget. That sales is equal to beta naught plus beta 1 into TV budget plus error. What is my null hypothesis in this case? Can anybody respond? My linear regression model is sales is equal to beta naught plus beta 1 into TV. Let me see that model. Yeah. In this case, what is the null hypothesis? My null hypothesis is that TV has no effect on the TV budget, has no effect on the sales. That means what? My null hypothesis H0 is beta 1 is equal to 0. Alternate hypothesis beta 1 is not equal to 0. Or in simple terms, what I want to prove, that I have to take in the alternate hypothesis. What I want to prove is that TV budget has an impact on the sales. I'm a marketing manager. I want to go and ask for more advertisement. So what I have to prove? I have to prove that TV advertisement has an impact on sales. So that I keep it in the alternate hypothesis. Null hypothesis, what null hypothesis, I say that beta 1 is equal to 0. When beta 1 is equal to 0, this x factor vanishes. Then my equation becomes sales is equal to beta naught plus epsilon. Am I able to make sense?
Yes, sir. Yes, sir.
So, if I can reject H naught, if I can reject beta 1 is equal to 0, then I can say that there is some impact of TV budget on sales. So here T statistic is coming to 17.67. So what I say is that what is my conclusion is that whenever T or modulus of T is greater than 2, then I say that there is some significance to my model. Then I say that I can reject my H naught. So this p-value says what is the probability of observing this much higher t value. So basically, what is my aim in statistics? In statistics, I want to explain my variation. In statistics, I want to separate chance variation from significant variation. If I say that this large amount of T is happening not by chance, what is the probability of this T value coming 17.67 by chance? What is that probability? That probability is saying 0.301. That means very small probability that this T statistics is coming by chance. A very small probability. That means this model is having a significant explanatory power. It is not due to chance. Then I say that reject null. That is the importance of this p-value. Because this is a bit confusing. Now statisticians, econometricians, scientists have come up with something called 1 by p. If I keep 1 by p here, then how much it becomes 1000, it becomes something like significant figure, a large figure. Then I can intuitively understand. Am I able to make sense, sir?
Yes.
No, I have tried to summarize because of weak voice of Dr. Basha, sir.
No, no, sir.
No, yeah, I hope you are not hesitating in saying yes.
Yes.
No, I am trying to.
Sir, this p-value is less than 0.001 means I am not able to understand why this is 0.001 means what it is signifying. I am unable to understand.
Yeah, madam, please. I will just summarize it. So in statistics, I want to know whether something is due to chance or whether there is any something significant is there. Only when it is significant, I can act upon it, I can take a decision on it. Now, when I done this regression, what I am saying, if T statistic is modulus of T is greater than 2, it is significant. That means it is not occurring by chance. Now this p-value tells me what is the probability that this T statistic is coming due to chance. What is the probability here? Very less probability, minute probability.
Yes.
So there is a large probability that there is significance in this T statistic. There is significance in this model. There is significance that Beta 1 is equal to 0 can be rejected. You go to the regression model. That means there is a significant impact of TV budget on sales. What is the probability that TV budget is driving sales only by chance? That is this 0.0001. Am I making sense?
Yes, sir. Yes, sir.
Okay.
Yes.
Now I am confirmed by seeing the strength in Varsha's voice. Madam, I think we will ask Madam.
Yeah, Rashmi ma'am.
Yeah, sir. So it is showing that the probability is very less. So
Very less.
in the reverse order, you are considering since the probability of happening this thing is less. So in the contrary, we can say that TV has an impact on sales, right?
Yeah, excellent, Madam. Excellent. I'm very happy that. So because it is a lot of clarification needed here. So I want to reject my chance variations. So I want to separate out what is due to chance, what is due to significance. So my aim is to reject null. I want to have sufficient evidence so that I can reject null and go for my model. I can apply my model only when I can reject my null hypothesis H0. In this case, H0 is equal to H0 is beta 1 is equal to 0. What is beta 1? Beta 1 is the coefficient of TV budget. What is my model? My model is sales is equal to beta naught plus beta 1 into TV budget plus error. I'm unable to write on the board. That's why I have to resort to my vocal power. Madam, are you clear?
Is there any kind of specific value for P? Means below that I will be rejecting, and after that you have to accept, like that. Any specific value?
Yes, that is normally 2. If modulus of T is greater than 2, why 2? 2 means because it is above 2 standard deviations from the mean. Have you studied normal distribution, madam?
Yes, sir.
So whenever I say that it is more than 2 sigma, the 2 sigma goes into the tails. If it is 3 sigma, it goes further into the tails. So which is going into the tails is there is some significance. It is not due to normal variation. Suppose normal average height of persons in India is suppose 6 feet or 5.8. If suddenly some observation is there, then it says that it is not due to normal variation. It doesn't fit into normal distribution. So that's why nowadays, because of this somewhat hazy thing, the statisticians are calculating 1 by P. Suppose 1 by P will come here over 1000. So then I can intuitively understand that it is a high value. That is this 1 by P is high. So this model is significant. But am I making sense?
Yes, sir.
So the soul of statistics is hypothesis testing. Unless I have a hypothesis, I can't formulate a model. I can't write an R code. I can't do anything. Why I am learning R? I am learning R to do some decision making. To do decision making, I need some hypothesis. Unless you understand how we are forming hypothesis and what is the intuition behind rejecting a hypothesis or not rejecting hypothesis. There is no concept called accepting hypothesis. Either reject H naught or don't reject H naught. That is how our statistical inquiry and decision making goes here. Formulating a correct hypothesis is the heart of all your data science problems or machine learning problems. What type of questions I have to put to the data? Then the details comes into picture, like how to go for statistical methods, how to code it, and all these things. Any other question? I would love to interact so that we can have more. I think some more questions on the chat box, sir.
Already we discussed it, sir.
Oh, okay.
From audience side, if you have any queries, please.
Otherwise, I may request madam to summarize. Then we can call it a day.
Yeah, sir. Sir,
I
Rajendra,
I request madam to summarize what we are trying to explain in this session.
So before that, I would like to ask one more last question.
Sure.
Don't mind if we have time.
My pleasure.
Since we have been talking about T statistics.
T static,
Yeah. Today's session is very much successful or very much interested. Is it by chance or by well preparation or by the resource person had excellent knowledge? Would you explain with respect to T statistics, sir?
So then we have to go for multivariate, multilinear regression. So
Okay.
here, Dr. Rajan sir,
Sir.
satisfaction of students is the dependent variable. Independent variable is the students' enthusiasm and the lecturer's skill, lecturer's preparation, and the arrangements, the internet connection, all these things plus error.
Yeah.
So you have to run the MLR, multiple linear regression, and find out the T statistics.
Very good. Excellent, sir. That's why it is essential for MBS before MBA, it is BTech. So both the technical and management skills and how to convince the people at the same time, how to improve the things that whatever that is expected. That is only possible with the help of the combination of technical and management people.
Thank you so much. Actually, you helped me to refresh my R because I have not gone through this R studio long back.
Okay. So anyhow, it's a well-organized presentation as per our expectations.
Thank you.
Really speaking, today's session gave us actual flavor of data analytics and statistics with real-time examples. So generally, as a computer engineer, we just write the code and we didn't think about other relationship, like how a doctor sees his patient, and not with respect to feeling and relationship and all. So there's no exaggeration. Really, I enjoyed this session, even though I learned some of these algorithms discussed today, earlier in my studies, as well as in my research also. I understood that how to use these statistical techniques or methods in real-time problems. So thank you very much, sir. From my side, I'm very much satisfied. I wish that other participants also got some sufficient knowledge and awareness on using the statistical methods, how to use these statistical methods in real-time applications. I wish that this may be useful for the researchers also. So thank you very much, sir, for sparing your precious time and sharing your knowledge with our participants, especially for my faculty members and other participants also. As you mentioned that if there is a chance of summarizing by madam, I request ma'am to summarize this, or otherwise I ask the Bhasha sir to conclude and close the session for today.
Yeah, thank you, sir. First of all, as already Rajendra sir said that today's session is wonderful, and you have shared well knowledge on regarding the statistical analysis, and for the researchers also definitely they will implement these concepts in their research. Thank you very much, sir. And
Thank you, sir. Thank
yeah, now I request all the participants, please switch on your video for a while.
If possible, you can take 1 minute feedback from madam, because madam has put a lot of questions.
Yes.
Thank you, sir. Thank you very much. Actually, I am doing research in R. Actually, I am using structural equation modeling and that lava
Great.
package. And I am just
Oh,
struggling
great.
with this P value, T statistics, Z value, everything now it's jumbled up in my mind. So that's why, and that's why I was asking for so many PPTs and the references, because I am just looking for research in this area.
Great,
And thank
great.
you very much for clearing my concepts in this area. Thank you very much.
Great, madam. Great.
Thank you.
I'm very much.
Ma'am, I'm Dr. Rajendra, head of the department. I don't know from where you are. I wonder that if you can in touch with Dr. Dhananjay sir, I think that this will be very much useful for your research.
Yeah,
will
sir,
generate
kindly
ideas.
please share his mail ID or something by which I can
Sure.
contact.
Sure. Definitely, we will share the information.
In the group itself, WhatsApp
sir,
group, we will put all the details.
Yes.
Sir,
Yes.
a small, actually, sir, is my voice is audible? Sir, is my voice is audible?
Some disturbance is there.
Hello, sir, is my voice is audible?
Now it's okay, ma'am. Please go ahead.
Sir, actually, I also had a doubt about this. I thought the data mining warehousing subject in the previous semester, sir, and I had a lot of confusion regarding this by using the R software. But with the help of this session, maximum the doubts what I had, it was cleared, sir. Thank you so much for arranging such type of session, and I request you that provide the details or the mail ID of the sir, because as ma'am already said that, and I too also interested to do a particular research topic or research on this what you said today on the yesterday's session, sir.
Sure. Definitely, we will share the info of our resource persons, and also share our presentation from the resource persons. Definitely, we will share.
A lot
Definitely.
of practical
My pleasure to
examples
share.
had said, sir. The practical examples, the live examples also said. So the doubts what I had, almost it was clear, sir. The session helps me a lot, sir. Thank you so much.
Thank you.
Thank you, madam. But I'm able to help some people of such expertise, and this thing I'm very happy to have participated in this.
Yes.
Sir, Bhasha sir, have you had your snap?
1 minute, sir. Already I have.
Since you ask all the participants to turn on their video.
Sir, even though one more I will take, sir. Just a minute, sir. Okay, sir. Thank you.
Thank you.
Thank you.
Thank you, Dhananjay sir. And from my
Thank you,
side,
sir. Thank you, Dr. Rajan, sir.
I am very much thankful for all the participants. And tomorrow also, there are 2 more topics to be continued by Obule sir and
Krishna
Krishna Prasad sir also. I request participants, don't miss tomorrow's session also. As I said yesterday, it is really useful and exciting session. And tomorrow's session will be more practical oriented. If possible, all the participants, please stay back. Thank you and good night.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you once again.
Thank you, sir. Thank you.
Good night to all.
Good night to all. We can.
Thank you, sir. Thank you.
Okay.